Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zulhazri Bezakaria. I will present about the activity 1, the resistance identification. The identification we can get from the color code from the resistance. The color code given based on the value of the resistance and the tolerance. For example, I will choose 52.1 k ohm. The color code is green, red, brown, red and gold. This we get 52.1 k ohm, so it means 52,100 ohm. This is the first digit, the second digit, third digit and multiply. So the tolerance is 5%. So for the first digit 5, so green. The second digit 2, which is red. The third digit 1, which is brown. And this is multiply, so 2 digit means 100, so red. The tolerance is 5%, which is gold. So 52.1 k ohm, we get green, red, brown, red and gold. After that, I'll present about the activity 2, the current simulation and calculation. So this is the simulation of the current measurement. This is the after load, and this is current measurement. This is the current measurement after load, and this is the current measurement before load. So first, we get value 150 ohm. Then we run the simulation. We get 67 milliampere. For after load, we get negative 67. For value 200 ohm. So for 200 ohm, we get the value 50 milliampere. After load, negative 50 milliampere. So for the value 300 ohm, we get the value 33 milliampere. For after load, we get negative 33 milliampere. After we get the result, we can fill the table. Then for the calculation, we use the formula I calculation equal to U input over R, which is load. Then we get the same value, 67 for 150 ohm, 50 milliampere for 200 ohm, 33 milliampere for 300 ohm.
Hi everyone, my name is Nityan Raja. My matrix number is CE190043, And today I would like to present about activity 3, which is voltage simulation and calculation. So this is the figure 7.6 that we need to simulate. So let's we look into the procedure first. So these are the procedure that we have done for this activity 3. So the circuit as shown in figure 7.6 has been simulated using Proteus software, and the value of simulated voltage across our resistor 1 and resistor 2 has been recorded into the table 7.3. U1 and U2 had been calculated using the formula given from the circuit, and the calculated value had been recorded into the table 7.3. Step 1 and step 2 are repeated by using resistance as specified in table 7.3. So let's we look into the calculation first for the U1 and U2. So for U1, we have done this calculation using this formula given in the lab sheet. So these are the R1 and R2 values that we are used for in order to find U1 and U2 based on table. So this is the formula that we have used for resistance 200 ohm and 100 ohm. We have obtained U1 and U2, which is 6.67 and 3.33 volt. For resistance value 200 and 150 ohm, we have obtained the value which is 5.71 volt and 4.29 volt. So for resistance value 200 and 200 ohm, we have obtained 5 volt and 5 volt. For resistance for 200 and 300, we have obtained the voltage which is 4 volt and 6 volt. So let's we jump straight to the simulation. So this is the circuit design for this activity 3 that we have designed using Proteus software. So this is the voltage source. So this is a resistance. So this is R1, R2, and the voltmeter is connected in parallel to each of these resistors. So for the first load, which is 200 ohm and 100 ohm. So let me change this value into 100 ohm. So the voltage that we are using is 10 volt. So let's we simulate this value. So we obtained 6.67 and 3.33 volt for resistor 1 and resistor 2. So let's we use load 2 and we look into the simulated value. So for the second load, which is 200 ohm for R1 and 150 ohm for R2, so let's we simulate this, and this is the voltage that we have obtained. For R1 is 5.71 volt, for R2 is 4.29 volt. So let's we look into the load 3, which is 200 ohm for R1 and 200 ohm for R2. So let's we simulate. So as you can see, we obtained 5 volt for R1 and 5 volt for R2. So let's we uh, use the last resistive load, which is for R1 we need to use 200 ohm, and for R2 we need to use 300 ohm. So let's we simulate this value. So these are the voltage that we have obtained. For R1 is 4 volt and for R2 is 6 volt. So let's we look into the result for this activity 3. So these are the resistive loads that we have used, which is R1, R2, which consists of the loads that we have used in the simulation. So these are the voltage that we have obtained from the simulation, and these are the voltage that we have obtained through manual calculation by using the formula given in the lab sheet. So what we can say about this activity 3? So we can say that the simulation value and the calculated value is same. So Ohm's law come into play to find the voltage for each of the resistor in series, and the voltmeters are connected in parallel because parallel circuit have the same potential difference. So let's we look into activity 4, which is voltage and current simulation and calculation. So this is the figure 7.7. This is the figure that we will be used for simulation. So let's we look into the procedure. So a circuit has been simulated as shown in the figure 7.7 using Proteus software. The value of U1, U2, U3 and U4 has been simulated and recorded in table 7.4. The value of I1, I2, I3 and I4 had been simulated and recorded in table 7.4. The result will be compared with the calculated value. So these are the calculation that we have used for this activity 4. So as you can see, based on the figure 7.7, we have load. This is R1. For 200 ohm is R1, 150 ohm is R2, R3 is 100 ohm, and R4 is 300 ohm. So as you can see, R3 and R4 in series, so we have add this both resistive value, and R2 and R3 R4 is in parallel, so we have used the parallel resistance formula in order to find the single load value for the this resistance. So the total resistance will be calculated by using normal addition. So this is the formula that we have used in order to find the I1, V1, V2, I2, and we have used Kirchhoff's current law in order to find the current I3, and we use Ohm's law to find V3 and V4. So these are the basic explanation for this calculation. So let's we look into the result. So before we look into the result, so let's we jump straight to the simulation. So this is the circuit design that we have designed using Proteus software. So as you can see, this is the R1, R2, R3, and R4, which has a resistive value of 200, 150, 100, and 300 ohms. So as you can see, there is a voltmeter connected parallel to the R1, R2, R3, and R4, and the current the ammeters are connected in line with the circuit. For branch 1, it will be connected series with R1. For ammeter 2, which is connected series with R2, and for the ammeter 3, which is connected to the R3 and R4. So these circuits are connected in a knot. So this is the knot for this current circuit. So this is where the Kirchhoff law will come into play. So let's we simulate this circuit. So as you can see, we have obtained values which are 6.47 for R1, so which is V1. So for V2 we have obtained 3.53, for V3 we have obtained 0.88, and for R4 we have obtained 2.65 volts. So for the ammeter, the I total, so which is we obtained 32.4 milliampere. For I1 we have obtained 23.5 milliampere, and for I2 we have obtained 8.82 milliampere. So these three current values are in milliampere, as you can see in this ammeter. So let's we look into the result. Okay, so this is the result that we have obtained. So this is the simulated and calculated voltage value for this table, which is table 7.4. So in the middle of this table we have obtained all the simulated values from the Proteus software, and this is the calculated value that we have obtained using the formula. So this is table 7.5, which is a simulated and calculated current value. For the current, the simulated value that we have obtained from this Proteus software here in this simulated value. For the calculated value, we have calculated using some formulas for this activity 4. So what we can say from this activity 4? So based on this activity 4, in order to find all the calculated value, Ohm's law, parallel resistance formula, and Kirchhoff law current is used. So based on the result obtained, the calculated value and the simulated value is same if the decimal values are not accountable in the calculated value. So as you can see from this result, the simulated value is based on the Proteus software, we obtained 32.4 milliampere. So from the calculated value, we have obtained 32.35. So when we round off this calculated value, we will obtain the same value as this simulated value. We will obtain the calculated value as same as this simulated value. So as you can see, for I2, this is also same. We have obtained 23.53 for this calculated value. When we round off, it will be same from this simulated value, it will be same with the simulated value. I3 also same, but in this case, for I3, when we round off this value, we will obtain 8.9, and here we will be 8.8 only for this simulated value. So let's we look into the voltage. Voltage also same. If we do not account the decimal values, the values for simulated and the calculated will be the same. So that's all from me. So I would like to pass this presentation to my teammate. Thank you.